we'll do y2, the second y, minus the first y, y1. That's the rise. So at the bottom now, we're going to do the run. And our run goes side to side. When you think of a graph, what goes side to side, the x's or the y's? X's. So that's why x's are on the bottom, is because it's really still rise over run. We're just doing it with the numbers rather than counting from space to space to space. Okay? Which makes sense. If you look at these points, would you want to plot these 2 points on a graph and find the rise and run on all of these? Those big numbers? You're going to need like a huge sheet of graph paper to do that. That's too much work. I'm just saying. Alright, so we're going to find the slopes of these equations. I'm sorry, of these points. It says which lines are parallel, which lines are perpendicular. So remember, a line has to go through 2 points. It has 2 points listed for us. So we're going to find those slopes, and then we'll compare them as we go to decide if they're parallel or perpendicular. Does anyone remember parallel lines have what type of slopes? Here was positive, yeah. These ones are positive. They always have to be positive? No. What was the slope of our regular line and the slope of our purple line? A regular line was 7/3. They're the same. They're equal. Okay, so we can make that at the bottom. The lines have the same slope. What about perpendicular? When we did perpendicular, opposite, so it went from negative to a positive, what else happened? Yeah, they flipped. Like this, when 1/3 flipped to 3/1. Does anyone remember what do we call that when we flip a fraction? There you go, reciprocal. So perpendicular lines, you have to write this kind of small because I didn't give you probably enough space here. Have opposite reciprocal slopes. So as we find these slopes and we compare them, those are the things we're looking for. Either we're looking for 2 slopes that are the same, or we're looking for slopes that are perpendicular reciprocal. So one's positive, one's negative, and they're flipped. Alright, so we're going to start with line A. Line A says 10, 3, 16, 11. I'm going to start by labeling these points. So I always like to label X, Y, X, Y. I always do that first before I even start thinking of the numbers. This first XY is my first one, so I like to put 1s there. My second XY is the second one, so that's 2. Now, is there a reason why I typed this one second and this one first when I made the sheet? No. So could I have labeled this one the second one and this one the first one? As long as the 2's go together and the 1's go together. So I just always label it this way. It just makes my life easier. So we're going to start with Y2. What number is our Y2? 11 minus our Y1, 3, over X2, 16, minus our X1, 10. And then according to order of operations, these are grouped together in the numerator, and then these are grouped together in the denominator. So we're going to do that subtracting. So 11 minus 3, what's 11 minus 3? Anyone? 8. Thanks. 16 minus 10? 6. So we get 8 over 6. Can we simplify 8 over 6? Yeah, remember simplify means to divide top and bottom by the same thing. We're actually going to leave it as an improper fraction. So even though somebody noticed this is a improper fraction, we could make it into a mixed number like 1 and 2/6. But we're not worried about that today. We're going to keep it as a rise and a run. So What can we divide both 8 and 6 by? 2. Good. So 8 divided by 2 is 4. 6 divided by 2 is 3. So currently right now we only have one slope. Our slope is 4/3. So we're going to move on to a different line and see how that compares to 4/3. Do you guys want to go to B, C, or D? Yeah, I would go to C. For some reason I would have put B. I don't know why I did C there, but I did. Alright, so over here again I'm going to label X, Y, X, Y. Then I put in those numbers, 1 and 1, 2 and 2. Alright, we're going to start with our second y, the y from the second point. So what is the y from the second point? Good, a positive 15 minus, what's the y from the first point? Negative 1. Now you can write 15 minus negative 1. Some people like to change that. What's the same thing as subtracting a negative? Adding, and put that negative in parentheses. That way I see that that's a subtracting sign and that's a negative sign. And some people just write it as it is and they feel fine about it. Do whatever is going to help you get that, the best way for you to find that answer. Alright, on the bottom we have our second x. Which number is the second x? Negative 15. Minus, what's our first x? Negative 3. Yep. Alright, if you look at this and you're like, what is happening? It's okay to use Desmos. Those of you that maybe you like these problems, when we did that 15 minus negative 1, that tells us to go on the opposite of the negative. So we're really going to do 15 plus 1. And what do we get? You guys are just the most chatty today. 16. Wonderful. Good job. Alright, and then on the bottom we have negative 15 minus negative 3. And we get negative 12. What can I divide both 16 and 12 by? 4. Yeah, or I could do 2. If I divide by 2, I might have to simplify again. So if you can simplify that, go for it. Another way you can do that is by using Desmos. You type it in as 16, and then I use that dividing by, and it puts it as a fraction for us. Negative 12. Okay, and then to get that fraction answer, there's a circle with the 2 boxes. So if you hit that circle with the 2 boxes, it will simplify it for us. Okay, so if simplifying is not your strong suit, that's not what this lesson is about. This lesson is about finding slopes. So if you need to, use that simplify button on Desmos. Alright, let's compare the slopes that we have. Are C and A, are they parallel? Are they the same? They are? Yeah, one's negative, so are they exactly the same? No. Okay, are they opposite reciprocals? They're opposite. One's positive, one's negative. Did it flip, though? Flip would mean the 4 and the 3 switch spots. So it'd be 3/4. Nope. So right now, those are neither parallel or perpendicular. We have no answer so far. We got nothing. That one was maybe, I don't know. Never mind. I don't know what I'm saying. Just talking. Alright. So for line B, this time I don't have enough space to write my X and Y, so I'm not going to. If you'd like to, and you can fit that in, go for it. Okay, here I'm thinking, what is my second Y? What is my Y2? I'm not looking at you. Which one is the Y2? Somebody said it. I just ignored it for a second. Negative 11, good. Minus, what's our Y1, the first Y? negative 14. And then on the bottom, we're doing our x's. So what is our x2, our second x? 11. These ones on top of each other should match up. They should make a ordered pair. So if these are from different ordered pairs, something didn't go right, but they came from the same one. Minus, and then same thing, these should come from the same ordered pair. So what's our first x? 15. All right, negative 11 minus negative 14. Oh. Negative 14. We get 3. 11 minus 15. We get negative 4. Now the only thing that's not quite right about this is we don't really love to say 3 negative fourths. So that negative, we want to think about our answers. Should our final answer be positive or negative when we divide this? Is 3 divided by negative 4, is that overall answer positive or negative? Negative. A positive divided by a negative is a negative. So when there's only one negative, we always either put it out front or we associate it with the top. And we say that whole thing is negative now. Negative 3/4. So very rarely do we put it on the bottom. Alright, so with negative 3/4, are there any that are the same? Exact same as negative 3/4? No. Are there any that are opposite reciprocals? Yep. So we want the opposite. So opposite means positive to negative or negative to positive. So this starts negative, so what kind of answer do we want to look for perpendicular? Positive, and then we want to flip it. So I'm looking for a positive 4/3. Which line had that slope that will give us a perpendicular line? A, because A went from that negative to a positive. These ones are both negatives, so they can't be perpendicular. They have to switch those directions. So up here at the top, I'm going to kind of write my answers here because I didn't really leave space for us to do answers. I don't know. And we know that A is perpendicular. We're going to use that upside down T. That means 90 degrees with B. All right, let's do D and see if D matches up with any. So we're going to start with our second y, y2, 10, minus our y1, negative 2. Hamsa's crushing it today. x2, 7, minus our x1, negative 2. This one was kind of nice because our x and y here was negative 2, so we didn't really have to think too hard. Say negative 2 for both those. Alright, then we got 10 minus negative 2. And we get 12. 7 minus negative 2. And we get 9. Gave you a hint there by putting another equal sign.
So we simplify 12 to 9? What could we divide 12 to both sides?
And when we divide by 3, 12 divided by 3 is 4. And 9 divided by 3 is 3, so 4/3. Alright, so here we have 4/3. Do we have any of the lines that are parallel that are exactly the same slope? What?
Yeah, which ones?
A.
A and B. Yeah.
Good. So A is, and for parallel, we use usually it's a little slanted. A is parallel to D. That means they're running side by side. Are there any that are perpendicular to D? That are opposite reciprocals? Yeah, which one? Audi Coffee, you're so close. Remember, C is an opposite, but did C flip it? No. So we want to go from positive to a negative, but we want to flip. So B. So we also know that B is perpendicular to D.